Hello again, everyone. It's been a long day, but I'm sure that we share the feeling that it's been the best way that we can spend the time today. And for the last session of the day, we again have with us Peter Solymos, a senior data scientist and ecologist, and as you will soon see, an expert in animal population modeling. His recent work includes developing more accurate status and trend estimates for North American bird species to better understand population changes over time. Also, a tool for natural resource managers to estimate the cost and benefits of specific recovery actions for animal species. Today, however, we are going to take a look at, well, adaptive moose surveys. To effectively manage wildlife populations, it's important to have knowledge about species distribution and abundance. And Peter will demonstrate how Shiny transformed and impacted the Yukon government's moose monitoring program by showcasing, great name by the way, moosecounter, which aids in estimating moose population, or meese, and composition, and allows for better management of these animal populations. Just a friendly reminder, if you have any questions to Peter, post them on the chat. We'll be collecting them. And side note, great panel on innovations in Shiny with Eric and the others, Peter. Great to have you now, but yeah, let's talk moose now. Off to you.
Thank you. I'm happy to be here, and thanks for the opportunity to close out this incredible session and this first day of this incredible conference. And usually when I talk about Shiny, I'm talking about deployment and how you can use a server and use many servers and how to make it available to your users. This is going to be an exception when we are going to use Shiny or see how to use Shiny in a desktop application and why we might want to do that. You might already know the answer, or I will give that to you at the end or during this talk. So thank you for that introduction. I'm going to talk about the moosecounter. This is the name of the R package and the application. And this was just the first name that came to my mind. And I'm not sure that all the team has agreed with me on this yet. And they are free to let me know if they think otherwise. But that's how it goes right now. And this is a Shiny desktop application for adaptive moose surveys in the Yukon Territory in Canada. And each of those words is going to get some meaning as we go through the slides. But before we jump in there, there's a whole team behind this. And this goes back to, again, story time at the end of the day, how this all started. And this was a need from government who wanted to know how many moose are out there. And so Sophie here, who is the moose biologist with the Yukon government, was doing work with Subhash Lala, who is now a retired statistics professor from the University of Alberta. And he was helping with the statistics and figured out a way that goes beyond what was currently the status quo in moose monitoring and population estimation. And so they had this project going, but as you will see, they needed the code to be a bit more user-friendly and maybe have a graphical user interface so that it's not just them who know the statistics and know R from the command line, but someone else who can train and teach, and in the field will be able to click on things and get some outputs and inform them decisions that way. So it came to me and I turned it around and we got an app running, and then we had some trouble. So this was back in more than almost 10 years ago. And recently, the originally written app was starting to failing. And so we had to think about how to do it in a more up-to-date fashion. This is when Steffi came into the picture, helping me out with some Shiny development. And her endless patience and attention to detail really paid off, because I think at the end, we got a really nice Shiny application. Hope you'll agree with me on that. So first question, why? Why do we want an app in the first place? We're trying to answer a couple of questions here. First is, once you get a number, this is how many moose you've got. And in the Yukon, population sizes are not extremely high, even considering the immense amount of landscape out there for moose. Think about hundreds in a management unit, or sometimes thousands in bigger areas, but not too many. And that's why it's really critical to know the exact numbers, because if you start harvesting or hunting the moose, then all of a sudden you can quite quickly just go down to zero, basically. So is the population above a minimum threshold so that we give out harvest licenses? Then how many of these licenses can we have for the next season? So every year we need to know something about the health of the population out there. And then looking back over a couple of years, is this harvest sustainable? Do we need to change something? And is the moose, how it's currently doing recruitment-wise, so how many newborns we see or younglings, is that going in the right direction so that we don't really have to worry about the future of the population? All of this requires some data to begin with, and because the landscape is just too huge, it might be a problem to go to every place. And as a result, we might rely on statistics to tell us what to expect at places where we haven't really taken any samples from. This is a management unit close to White Horse, which can be seen down here somewhere. And as you go to these cells, which are highlighted in bold brackets, then you survey the moose, you count how many you've seen from a helicopter, and then you put it into an Excel file or some kind of database. And once you have this data, then you can stratify the landscape. Is it like low moose abundance, which is most of the green that you can see here, or high abundance? And the state of the art in terms of extrapolating out to all of the other areas might be to just take the mean within these areas, and then based on that, you can get a stratified sample total moose population plus some variance around that, so you would know uncertainty. And as you will see, this might not be the best approach. And also for this to work, to get a simple random sample, you might have to go to many of these cell blocks. So how we can maintain the quality of our inference while doing less of the surveys? As it turns out, you can do adaptive sampling, which means you start small and then you add more to it. And as you increase sample size and you go not just to a random location the next day, but you pick the next location wisely, you can improve things substantially. And to just speak to the cost a bit more, early winter moose surveys are done by helicopter because there aren't many roads in the Yukon. And even from the roads, you can't get really far up into the mountains and down into the river valleys where the moose can be found. So you need to fly around and then spend some time and money and gasoline by doing that. And that's why, because it's so involved and so costly, 2.5 million spent over the past decade only indicates the fuel costs. So there is staff time involved and all the people who are doing the analysis then. So it can be a lot more over a decade. But then from the helicopter, you see something like this, which is a pretty big crowd for moose. This is like a cluster of them. And then kind of need to tell apart the bulls from the cows and collect all kinds of information just by zipping through the landscape. And this then gets entered into a data set, which every night when they are done with flying around in the helicopter and go back to the base camp, then they enter the data and figure out where to go the next day. And this is another picture in a bit more light. And if you can spot the moose, then you should probably go and sign up as a biologist to do this fun survey in the wild. You can see them here, a pair. So the way to reduce sampling effort, as it turns out, is to use expert opinion to begin with, which might give you an idea about this low-high stratification, because people have been hunting moose for millennia, and they might know where to find them. So if you ask the hunters, ask the people, ask the indigenous people out there who make their livelihood from this, then they might be able to tell you, go to the burns, go to the shrubby places, because that's where moose are going to be hanging out. So once you have this stratification to begin with, you can have a random sample. Once you survey that, then you can start the sequential sampling. And you can fit a model to the data you already have and see what kind of predictions you get for the unsurveyed places. And you are not only going to get the number of moves that you can expect, but also the uncertainty around that. Now, the goal the next day is to go to as many of the high uncertainty places as possible, because that's how you can reduce this uncertainty. So then you start, for example, from Whitehorse, and every day you fly a transect, and these lines are 400 meters apart. So you go back and forth in a cell, collect the data, then at the end of the day, fly back, figure out where to go next. And at the end, you have, within a couple of days or a week, you might have sampled a large enough area, and then there's a stopping rule. Now the estimates are pretty good, or we need to go to the next management unit. And this is the distribution of the data at the end of the day that you see. Lots of zeros, as we would expect, and it's a really over-dispersed distribution. And these high ends, these are the data points that are going to drive the analysis. And also, these are the places where uncertainty is huge. Like if there's just one block where you spot 24 moose, maybe not in the entire territory you are going to encounter such a number again. So these are very few and far in between, and this is where the uncertainty is highest. So if you know where to expect these high moose density areas, you can just go there. And that way, if you sample these places, then you don't have to estimate them, because by observing the number of moose, your uncertainty goes down to 0. So it becomes really certain that you saw 24. Maybe it was 25, but it is unlikely that it was 0 or 3. Now, the need for the app came from, okay, someone needs to do this, and it's not just Sophie or a few other people who might know how to program in R, but they need to train a whole crew of people who are doing this every night, and not just in the same town, but different base camps. So wouldn't it be nice to have a user interface that they can use? So in 2014, which was a long time ago, I got a message. We should try to have a Skype call. At that time, it wasn't Teams or something else. It was Skype, as you might all recall. And then in a couple of months, this will be helpful for him, that means me, to get a start on writing a user-friendly version, because the stats was all there, but it was lots of loops and not very user-friendly, and no graphical user interface. So in a couple of months, then we had a first draft version of this, something called Deducer Moose plugin. And Deducer might not ring a bell for most of you. It is a Java-based user interface. So in the early days in R, you had TCL/TK and RJava, and Deducer and Jaguar were another way to write these kinds of user interfaces. But as the name implies, it relied on Java, which had some early hiccups. But once we got through installing the versions on the government computers, they were able to use it for many years, and then just update the Moose plugin package and go from there. And then our 4.0 came along, and nothing was working as the laptops were replaced. They had no way of reinstalling that again. And it looked like a good opportunity to maybe do something different than RJava. And we started with RJava at the time, because Shiny wasn't where it is today. And right now, if the same question would appear, which one should we pick, I wouldn't hesitate to start with Shiny. And that's what I would suggest. Don't go and try to do it in Deducer. So another email came a year ago or so. Would I be interested in putting it in a more stable platform? So in August, we had the first commit of this moosecounter package, which now depends on other kinds of packages, but which are much more easy to maintain and just install and get a working version going. Some of these cool apps that we have incorporated are Cable Extras, GGI Ref, OpenXLSX, and DT. I could mention a bit more, or if you go to the GitHub, then you'll see all the dependencies and suggested packages for the app to work. And just to give you an idea about the workflow, which I'm going to cover in the graphical user interface sense next, is you load the package, set some options, fit a model to capture total moose population. Then you predict it out to all those cells that you haven't seen, and then do the composition the same way. Composition means if there are 10 moose, how many of those are yearlings or bulls and cows, so that you get an idea about how the population is doing in terms of recruitment. And once this is all captured, you can test the package if the stats is right. And all of this is then encapsulated in the app. You can just type run_app and Shiny will start. So this is side by side how the deducer looked like when you were setting the options, how Shiny is looking right now if you start this app. In terms of the science behind it and in terms of the values, nothing has changed, but the look and feel of it, and just the fact that you can install and play with it and use it in action is really sets them apart. And I wasn't able, or I wasn't even trying to get these screenshots while I was preparing this presentation. I just pulled up from last year when we started working on it, and this is what we want to do. This is how it looked before. Maybe I could get it working, maybe I could not. So I wasn't going to risk it. Then once you set the settings, you load some data. In Jaguar and the user, you had a built-in interface. In Shiny, you need to present it in a table, do a bit more work, but it's not really that impossible to do it nowadays. There are lots of really nice libraries that can help with that. Once the data is loaded, you can do some exploration. You might not know what to expect in terms of what you're going to see in the next management unit, but you can fit some univariate exploration so that you can see how moose density or abundance is correlated with just shrub density. And based on this, you can start thinking about what kind of modeling might capture this distribution best. You can also include more than one variables. This is a simple regression tree that you can do here to use fire, like burnt areas, shrubs as covariates, and see how that correlate with the moose abundance out in the field from your observed data sets. Once you have an idea or reconfirmation of your initial thoughts about what might be driving moose abundance, then you can start fitting the models. And here we are trying to do a zero inflated model so that we have lots of zeros, as you saw. Those might be governed by a different set of covariates as the count. Once there is moose, how many you can find? Is it only 1? Is it 3? Is it 24? So you can build that up. And I really like this part of the deducer, where you can go almost like SPSS-like, adding the column names to the right-hand side for the count part and the zero part. But in Shiny, we could manage to build something very similar, where you can click add and remove the column names. And based on that, you can add models to the list, which will show up on the right-hand side, model 1, model 2, and then you can do some ranking in terms of which model might best capture your data. Then you do some goodness of fit testing, looking at residuals, where you get high residuals. Can you explain that? Maybe this is another spot where you need to go the next day, where you have some of these really high outliers in terms of the residuals. And this is really to help with planning. And the next piece also, when you look at prediction intervals, which is not just standard errors from the summary table, but also taking into account that now this is a negative binomial distribution, and that can be much wider. But luckily, moose numbers are not just 1s and 2s, but in the dozens or maybe above 20. So we get a sense of that uncertainty by running bootstrap-based simulations for the unsurveyed areas. And based on that, we have an interactive exploration using GGI-Ref, where you can click through the unsurveyed places and see, oh, this is really high uncertainty. What kind of landscape composition you can find there? Maybe that's a place where we should fly next. And once we observe that, and we can correlate that number to the predictor variables, we can reduce uncertainty elsewhere, maybe in this corner But then the next day you type in the data, go through the process again, and figure out which is the cell that you go to on the next day. So this is really helpful out in the field. And having it as a desktop application, if you have a browser and are installed with Shiny, you'll be able to do this even without Wi-Fi or any kind of cell coverage, which is often the case out in the remote wilderness. And then once you've collected the data, this is not something that happens in the field, but just after the data has been collected and the biologists are writing up the report, you can explore what is driving the composition of the total moose population out there, how many cows, 1 year, 2-year-old bulls you find, and so on. So you have all that information from the field, so you can start exploring that in terms of predictors, and then run also the modeling and the prediction intervals so that you can capture what is the expected value for total calves or total moose, and then what is the prediction interval around that 5th and the 95th percentile that is shown here. So this is a table that you can scroll down and find the download button, where you can export all of these outputs, and that's how you can start either putting it into some GIS software or putting it into reports, what at the end of the day you'll have to write up as a biologist. And of course, the proof of the pudding is the eating, and this app was written and the version of a usable version finished in October, so that these early winter surveys can happen by using the app. So it has been tested extensively out in the field. It survived, it got better, got some feedback, but nothing major in terms of that you cannot rely on the collected data. And now it has all been incorporated, everything checked twice. And what I can tell is that with R and Shiny, it is really easy to set that up. So that wasn't a complaint that we can't install this app, which is really good compared to the state where we were a bit more than a year ago. All you need is a browser, an R session running, or maybe you can all do this in RStudio desktop, which has the Shiny window popping up. So it's all good from that point of view. So R can be a really good graphical user interface. Now, of course, there's always something you can improve on the statistics. So we have some ideas of what to include in the next versions, how to get more accurate estimates. And of course, to mirror that, the user interface is also in active development. So if I have to summarize it up in 3 points, what I would advise to my previous self or someone who is embarking on a similar task today, you have to think about yourself, your users, and everyone else on the planet. So if you're thinking about yourself selfishly, just start with R. Don't try to use Java unless you really have to. But in this case, Shiny worked beautifully. Second, think about your users. Not everyone is a statistician, and so these graphical user interfaces can really help them to achieve a certain task that would otherwise might require a lot more training if you would expect people to do the same thing in the command line. For us, statisticians, programmers, it might be just 5 lines of code, but kind of get a feel of the data, get there. It requires a lot more, and that's why user interfaces are really needed. And of course, if you think about everyone else, if you have the privilege like I had to work on a problem that is really worth solving because you can improve upon, there's a need that really adds to this whole mix. And I'm really proud that we've achieved this. And it was also a real team effort. And I'm thankful for everyone involved as part of the statistics or just field testing. And I'm happy to take some questions.
Thank you very much, Peter. That's been superb. And indeed, there are a few questions. So let me start by the first one that popped up. Are hunting licenses granted throughout any given seasons, or are there any specific dates where there are opportunities to do so? For example, 3 times per season and so on. And the extra context is the person is asking in terms of course correction based on sampling over time.
Okay, so I'm not totally up to date on the regulation side of the hunting permits, but I know that there are some permits that they give out, plus some moose hunting that happens as part of the sustenance harvesting from indigenous people. And there is an estimate plus the hunting permits that were given out, and these need to be estimated, which is pretty close to the actual true number. But this is how they keep track of those. And the second part of the question, or second question, so each of these management units need to be revisited once in every 5 to 10 years, unless there is something like a planned development. So for example, if there's a road to be built or a mining operation, which is substantial in terms of its extent or perceived impact, then it might trigger some like a visit sooner than every 10 years, but that's usually how it goes.
And before the new approach, how often were those surveys conducted? Once every year or more often?
No, it was the same cycle. It was just the approach was different. And our goal was to try to reduce the survey it takes to get to a similar quality answer.
All right. So the next question comes from Eric. What are your thoughts on distributing a Shiny app in a self-contained way with Electron? I've had some painful experiences trying that in the past.
I haven't tried it, but I thought about it a lot. And maybe because I thought about it a lot, that's why I didn't fully commit doing it. But if I were to do it today, I would probably use Vue. And there's a really nice framework called Quasar, which from the same code base, you can build a desktop app, web app, iPhone, Android, and Electron app. So I think having the R session somehow combined with that would still be a challenge, if that's what you mean. But in terms of the front end and the reactivity, I think there are ways how you can get there. Yes.
Okay. There's also I guess a set of questions that are loosely connected. So first, from Guillermo, how are you planning to share the app between users, online or app files? And also a question from Ava, could you explain what you mean by desktop application specifically? And also a related question from Frederick, can we package it in OS-specific installers, so MSI, DMG, or some other form of deployable container?
Of course, container as a way to distribute it is really helpful, although in that case, the people who are interested should be able to deal with Docker. And right now, this is all our code, or the compiled code is coming from other packages. So as long as they can install Shiny and similar packages, they will be able to use remotes and use install _ GitHub, because that's where it lives publicly. So you'll be able to install it that way. So very minimal R package maintenance knowledge is necessary for this app to be able to install. And so the problem initially wasn't that someone who have done it before couldn't do it, but it just stopped working altogether because of the Java issues. And this gets around that. So if someone can go and install it once a year, that's pretty much what we are shooting for here. And by desktop application, I mean an app which on the skin, you might not see that it's running a browser in the background, what usually is happening with apps nowadays. And in the past, you were using maybe Java Spring or something else to write an application, which then you had to build for a specific operating system. And if you think about SPSS or Statistica, some of the statistical softwares which were out there and are still out there, they come in a graphical user interface format where you have an installer, you need to install that, and then you get an icon, you click on it. So you can do something like this, not necessarily through an icon, but you can only type one command in R, which is moosecounter : run app, and that will open the Shiny app, or it will tell you which port to look up in your browser. And that's how then from the browser you can do all these cool statistics that otherwise would be probably a bit more difficult if the user is not accustomed to the command line. And just visualizing it is much nicer, and sorting, going through the data.
Great. Thank you so much for that thorough explanation, Peter, and thanks everyone for sticking with us. We've got one more thing on the menu, which is a short summary of the day. So let's get to that.
Thanks so much.